Here also we have to assume the linked list is already created and the head pointer will be given to us. Suppose we are supposed to delete this particular node. So here also deletion requires 2 steps, and the step 1 is finding the before node. Find the before node or before node of node to be deleted. If I have to delete node 3, I need to find 2. Before node is important here. Same process will be same. In insertion, how you find the before node, here also you have to find the before node. But here the node to be is already in the linked list. Okay. So you need to find out if node at position 3 is to be deleted. Position 2 you have to find out. If you have to find delete node 3, then before 3 whatever is the node that you have to delete. Okay. The question again may come in any way. We will just go by key. Delete the node with key 3 because you already know how to find the before node, right? So let us take, if the key is given, how to insert that, how to delete that particular node. Then the second step is deletion. So in order to delete, change links and release the node. So here deletion is, if I have to delete this particular node, I can delete only that particular node's memory. Hard deletion here. It's not like array. We don't have to shift any data, anything. Just to delete this particular node. So in order to delete any particular node, we have to take care that we are not running into dangling pointers. Dynamic memory allocation, always there is dangling pointer problem. Where dangling pointer may come, if I release this memory, this address is already here, right? If I release this memory, this pointer will become a dangling pointer. So that problem I should not run into. That is why first I have to change the links so that I don't run into dangling pointer problem, right? So first finding the before node, then I need to change the links. So if I have to delete this particular node, I have to find out this node address. T is my before node. If I have to delete this node address is already in tnext address I need to change, right? Tnext value I need to change. So tnext, next it will point to the next node. If I have to delete this, then I have to make this as the next node of T. If I am deleting this, then in the link next is this one. So T next should point to this node. If the node to be deleted is S, I have to give it a name because I have to remember this address so that I can release it. If I have to release it, this address I have to send. So I have to remember this address in another pointer. Then T next will be S next because this node address is already here. Right? This node address is already in S next. So I have to make T next is equal to S next so that this link is formed. T next. Okay, so first T next I am remembering in S and this is the node to be deleted. T is the before node, T next is the node to be deleted. Okay, then T next is equal to S next. If S next value I am copying into T next so that T next is also pointing to the same node, S next is also pointing to the same node. Now release yes. Now this entire node is deleted from memory, released from memory by free function. This is all dynamically allocated. So you have to release them by calling free. So these three are the deletion steps. Finding the before node you already know. right? Here also, these 3 steps are for deletion other than head node. Okay, head node deletion again you have to specially handle. Key value some, okay, let me read the key value. I am writing only one insertion, one deletion. You have to write these things in a menu driven program where the same delete, insert, traverse, all these are options. Based on the given option, you have to run them continuously in a loop. Okay. So traversal after the deletion. So deletion for a given key. I need to first find out the before node. Okay, if I have to find out the key, I need to find out the before node of that key. That is second function I wrote now. Insert before a given thing. For that, you need to start. T is your head already, head pointer, while. So I need to take another pointer where I am storing T next. And then I'm making sure S is not null, and then S ID is not equal to key. T is equal to T next. Here also you need to do error handling. If the given key is not there in the linked list, then deletion is not possible. Okay. Now T is the node before the node to be deleted. S is the node to be deleted. T is the node before the node to be deleted. So using T, you will delete S. So how do you delete? T next is equal to S next, and then free S. This step here already it is done inside the loop itself. Already S value I have. Then this second step, third step. Okay. ID name. ID name. I need to insert first because first insertion function is called insert. Inserted at the third position. Okay, this is the list. The node to be deleted ID is 3. After deletion, this is the list. 3 is deleted. Okay. Now in this again there will be head deletion question also. Node to be deleted may be head. If the node to be deleted is head, that means there is a head pointer change required. Okay. So if this is the node to be deleted, then you have to make sure the next node is made the head. There must always be a heir. Successor should be there. Right? So if this node is deleted, then this is the new head pointer. So you need to remember this address first, then release this, then make this as the new head. A head deletion. You need to first identify if head need to be deleted or not. Given key belongs to head or given position is head itself. Okay, you need to first identify that you are supposed to delete the head pointer, head node. Then you need to first remember head next in somewhere. Then free head and then return yes, or using call by reference. You may return or use call by reference for the head pointer modification. Okay, here again you need to return something in both if and else cases. This if case is that you have to delete head. Else cases you may have to delete any other node. If head node to be deleted, then make a new head, return the new head. Else return the old head. Got it or not? Then assign the delete function to head pointer main function, because there is always a possibility of head deletion. Okay. Other than that, if take the head pointer as a double pointer, modify the double pointer. Okay, call by reference. Any one method you have to do deletion. Okay. And error handling also you need to do. Deletion function you have to write as another option. Do it using the key. Only one before node finding is enough. Okay.